Hey there, universe nerds. We know how stars are born and how galaxies grow, but here's the ultimate question. How does it all end? The universe had a beginning, the Big Bang, but will it have an ending, too? For decades, scientists have been trying to answer that, and while we don't know the final chapter yet, we have some pretty compelling theories. Today, let's dive into the most likely fates of the cosmos: the Big Freeze, the Big Rip, and the Big Crunch. The story starts with expansion. Ever since the Big Bang, about 13.8 billion years ago, the universe has been stretching outward. Galaxies are racing away from each other, carried on the expansion of space itself. For a long time, scientists thought gravity might slow it down. Maybe one day the expansion would stop and the universe would collapse back in. But then came the shocking discovery in 1998. Expansion isn't slowing, it's speeding up. Something mysterious called dark energy is driving the acceleration. And what happens to the universe depends entirely on how this force behaves. The first possible ending is the Big Freeze. If dark energy stays constant, galaxies will continue to drift apart forever. Over trillions of years, stars will burn out, galaxies will fade, and new stars will stop forming. Eventually, only black holes and dead remnants will remain, glowing faintly before even they evaporate through Hawking radiation. In this scenario, the universe doesn't end with a bang, but with silence, a cold, dark emptiness where time goes on, but nothing happens. The second, scarier possibility is the Big Rip. If dark energy grows stronger over time, expansion will accelerate uncontrollably. First, galaxies will be pulled apart, then stars will lose their planets, then atoms themselves will be ripped apart as space expands faster than the forces holding matter together. In the final moments, not even protons will survive. This is the most violent ending we can imagine. The universe torn to shreds by its own expansion. On the flip side, there's the Big Crunch. If dark energy someday weakens or reverses, gravity could win. Galaxies would slow down, stop, and then fall back together. The universe would collapse inward, heating up until everything is crushed into a fiery singularity. It would be like running the Big Bang in reverse. Some theories even suggest that after the crunch, a new Big Bang could follow, meaning universes might cycle endlessly, dying and being reborn in an eternal loop. Which one will it be? Right now, observations suggest the Big Freeze is the most likely. Dark energy seems constant, and galaxies are drifting apart faster and faster. But science is always evolving. New data could shift our predictions. That's what makes cosmology so exciting. We're literally trying to read the universe's ending while still living in its middle chapters. Even if we know the ending, don't worry. These events are unimaginably far away. The first stars will keep burning for billions of years. Even black holes will take googles of years to evaporate. For humans, the universe will still be alive and vibrant for longer than we can comprehend. Thinking about the end isn't about fear, it's about perspective. And that's the fascinating thing. By studying the end, we learn about the present. Dark energy, gravity, black holes, all of it connects to the ultimate fate. The fact that we can even ask these questions is incredible. Billions of years from now, the universe might go dark, rip itself apart, or collapse into fire. But today, the sky is still full of light, and we're here to witness it. So next time you look at the stars, remember, they're not just twinkling. They're actors in a grand story that has a beginning, middle, and eventually an end. The universe will not last forever, but the fact that we get to be here, now, asking how it all ends, might be the most beautiful part of the story.